Sphinx is going to perform a churn analysis on some data from a telecommunications company. This is for people's phone and internet plans, and the goal is to predict which customers are going to cancel their service in the next payment period. So we'll start up with a simple prompt to go find some data from telecom customers churn table, which in this case is in Snowflake, and then make a model for which customers will churn. So we'll give this prompt to Sphinx, and it'll get to work. First, of course, it'll connect to Snowflake using the predefined schemas that we've given it, and then go start to explore the data, do some EDA, do that quite quickly. It'll be able to find that there are several relevant features: the age of the customer, how long they've been a customer with us, their monthly charges, their total charges paid so far, which is obviously a composite engineered feature. And having done that, it can now do some data cleaning, prepare the features, and train a pretty basic, it seems, logistic regression model. In order to show us its performance, it'll give us a AUC curve with the AUC of 90%. It'll show us a confusion matrix, and it'll also show us the feature importances. It seems like the contract type is the most important feature by far, which makes sense. There may be different penalties for different contracts, but other things like how long they've been with us and if they have phone service or not, etc., also seem to be quite relevant. So now we'll go to Sphinx and ask it to try some more complicated models to see if they give us some advantage. So let's try a random forest and see how it compares. So Sphinx will be able to rerun this algorithm, now fitting a random forest. And you can see, of course, the AUC is actually a little bit lower. It's 89% instead of 90%. This indicates, of course, that the bigger model has not given us any lift. So the logical conclusion is probably to stick with the more simple model that gives us as much interpretation without any kind of additional complexity. But it does seem like the features are quite similar. The contract length is quite important. The total charges the customer is paying is also quite important to predict churn. And so let's actually have Sphinx do a little bit more of a thorough comparison of the two that we might be able to present to a stakeholder. So we'll go back to the prompt and say, can you write a markdown summary, that's a plain text summary, of the work we've done so far, and then the results. And Sphinx, having built context on the entire data science process, can now write us a nice little summary explaining that we've loaded the data from Snowflake, we've dealt with any data quality issues, we've dropped some of the invalid pieces of data, we've encoded the data, trained the models, and finally found that logistic regression is preferable because that's a little bit simpler. However, there are some small advantages to random forest. And here we can see that we've also addressed main data science concerns of using these types of models, including class imbalance, feature engineering, as well as building interpretation of what features are going to be used to drive the model's decision.